Okay, sorry, I had taken a minute to do some editing. Are you there?
Yes, miss.
Today is week 11,
Yes.
right? We will still continue with the theory classes. These two classes will be for completing your remaining classes on building components and retaining walls. I try to complete it. Next week onwards, you will have the presentation. So be prepared for the presentation. All of you upload your slides. Don't take much time. The slides are important. Let me go through the slide once, or at least a glance through, right? Before you go for presentation, it's good for you. Don't take until the end of the day, right? Upload all your slides priorly. Yes?
This way is a link for us to upload the.
I already given slides, so it is there. Did you check in MS Team? Presentation slides. I have created
Yeah,
a form for
already submitted the slides.
for 10 slides only I receive out of you 114 in the class. I received 10 plus. Don't wait until the day of your presentation. Please upload your slides priorly, right? Okay. If you cannot find, I will post again under your assessments, right? Easy for you, right? At the end of the class, I post again. You can add your slides inside the link. Follow the deadline. And then there are two more yet to submit your assignment. Oh, not you, your group. Titles all got. Schedule is ready. I have to post your assignment. Please give me until the end of this week. I want to complete this portion to give you the assignment together. From the day I post, you will get 2 weeks time to complete your assignment, question and answer type. Around 10 or less numbers, 7 numbers I will give, don't worry. It will take an hour or 3 hours for you to complete when you start writing. You want to collect any information, you will spend days together. So I am giving a 2 week span for you, right?
Miss, is it a group assignment?
No, all individual, no group assignment.
Okay.
Okay, let's proceed with this. Due to degradation, and so you need to choose the material which cannot corrode, especially when you are working with saline environment. Need special release agent, right? For removal, for stripping off your formwork, you have to properly grease it and properly remove it, or use the agents, reagents, the cream, the resins, which can easily which are easily helpful to remove your formwork, and the surface is smooth, right? Your components should not get affected. That's very important. Then third material is glass fiber reinforced plastic, right? All plastic types, PVC type, polyvinyl chloride, or all types of polyester mixed types of formworks are called third category. Strong and lightweight. The purpose is strong and lightweight. You are also seen in the video how they conveniently use the composite material, PVC material, especially how many what is the span they can use, how much folds they can keep it, right? To cover a big area, they minimize within. I mean, the whole building is covered by 30 panels, so they can maintain. The purpose is they can maintain a broader area less, so that you can reduce the number of panels you're using. It will reduce your logistics, right? Logistics, loading, and then carrying, handling, construction and dismantling. Okay, a combination, sometimes they use a combination of fiber and plastics. Comprises of polyester resin reinforced with glass fiber. I showed in the diagram last time, isn't it? How the polymer will look like. Glass reinforced polymer. You have many pictures. It will follow later. Okay, I show you later on. Glass reinforced one. Here. It will have plastic framework. Reinforcement will be by glasses, not by steel. Right. That's the purpose of using composite material like this, reinforced with glass fibers. Strong, lightweight with long service life, capable of producing high quality concrete with unique shapes. So it comes with different shapes to accommodate, especially at the corners, and as if the shape of the building is irregular, right? At crucial points of the edges, the meeting points, and the turnings, it will be helpful to customize at the site. That's why if it is steel, customization is so difficult. You need to weld it, you need to cut it, difficult for customization. But these type of plastics are easily manageable for adapting at the site. Thickness varies from 5 to 16 mm. So it is light, that's why it's light and manageable. If it is more than that, you have to think all these dimensions, and then criteria are given in the manual for Formwork. You can adapt them based on the strength, based on the purpose of the building. It will be, the type of building, it will be varying. Can we use more than 100 times? See that number of times. Steel, other things about 20-30 times, but this one because of corrosion, and this one 100 times if handled with care. Disadvantages similar with plastic formwork. So these types of polymer, or these types of mixed type of or composite type of reinforced plastic formwork can serve for 100 times, reusable, lightweight, and then what else? Less corrosive, many other factors which are applicable to a good formwork, right? Because of that, you can suggest these types of plastic glass fiber reinforced formworks. Example, is here. It's also here. A type of composite material. You can see the reinforcement here, right? The reinforcement, and this is the plastic, the PVC. These are the reinforcement.
Miss,
Yes.
what is the disadvantage of the plastic formwork?
Main disadvantage is if you load more, you need to know the criteria of adapting the thickness or the dimensions. If you load more, they may bend, chances of bending, right? At very high temperatures, there's chances of melting, kneading. These types of problems are there. When you use the mortars, if the mortar, the compaction, you're using mortars, right? You should avoid these types of getting heated. It may affect the material surrounding the concrete. All these problems are there, but you have to make sure that the dimensions you are using and the material you are using not affected by these factors. Mainly the temperature effect, and then the bending due to heavy load. If it is like people also using, right, during concreting, people also moving on the, if it is a slab, they have to move on the slabs and pour the concrete, and they have to prepare the reinforcement, bar bending, and then sometimes a small portion of concrete will be mixed on the site itself to edges or to level it. All these types of mobile loading should be bearable. So load bearing capacity of these load capacity of these plastics are limited, not like steel. So you can use hardly for the two-story, three-story building, but multiple numbers are possible. You cannot use for high-rise building. For high-rise building, you must go for steel, because as you go up, the weight of the structure is increasing, right? The weight of the structure, the building is increasing, so you have to provide proper formwork to bear the load that is coming in, all types of load that is coming in. Okay. You have any question? Hello? Are you there?
Yes.
Yes.
No question. No question.
Disadvantage is the weight. It cannot hold large weight like steel. Compared to steel and wood, it is not going to hold larger weight, and tend to bend due to weight, due to temperature. It tend to bend. These two effects are major. All other things we can follow as it is for the steel and concrete. The wood. This one is for aluminum, another type. This video you already seen. Okay, what are the main defects? Okay, what are the main defects? This is common for all types of formwork. But it is too worse if it is unattended in the beginning itself. That's why after after striping out your frame formworks, you should check. You should allow time for checking all these problems before you go for finishes. Later you will study about what are the plasterings, what are the finishing types you are going in. Before this, you have to thoroughly check whether these types of problems are occurred. Sometimes it is inevitable, right? So let's see what are the common errors, common problems that will occur in any concreting work due to formworks. Two types of common defects: blowholes, uneven color, small holes less than 15 mm diameter. Can you imagine 1.5 centimeter? Right. Starts with 1.5 centimeter. Small hole less than 1.5 centimeter dia. These types of holes due to expulsion of air, right? Sometimes it will take time for the air to expel even after compaction, right? It will release some air pockets inside the concrete. It will take some time to it is worse when you go for columns. It takes longer to travel all along the length of the column and to expel, right? So such cases are quite common in columns. So you need to avoid these types of entrapment of air or air bubbles inside by proper consolidation. If at all done, if at all complete compaction is done, you make sure that it is perfect. There may be some chances of getting less than 1.5 centimeter dia holes inside, caused by trapped air between the formwork and the concrete face. It is like most commonly it is affected by between the gap of formwork and the concrete face, or the when you start pouring, it will try to fill towards the end. It will start fill towards the end of the. It will start filling the surrounding surface of the formwork, right? Sometimes it won't reach even the end. Before that, it will settle or it will stop, right? And then if there is a chance that the compaction during starting of the compaction, end of the compaction, it will stop before reaching the end to end of the formwork. These types of errors will cause gaps between the formwork and the column, leaving an air pocket inside. With that, you are losing the size, you are losing the strength as well, right? That's why you have to find out whether there is a gap between the. All of you know that the formwork is made exactly the same size as that of the beam or column you're going to use it. It is design value, right? You cannot reduce or increase that value. You can increase, safer side. Although you lose material, it is safe. But the size, if the size is reduced, there's a chance of failure, chance of other types of problems due to that particular member. Uneven color, caused by irregular absorption of water from the wet concrete by the formwork material. Irregular absorption of water from the wet concrete, especially in wood. If you are using wood formworks, chances of absorption of water, right, before the concrete uses the water to settle down, reaches its strength, it will be absorbed by the wood. Number one, by that it is causing irregular absorption of water by the material, by the concrete, and then the stability, to achieve the stability, strength of the concrete, it takes time, but before that it is absorbed by the surrounding or the formwork or by any other means. Or temperature. The temperature is very high, right? Unfortunately, suddenly there is a very sunrise, the temperature is high, low and high. Suddenly it is very high or it is higher for longer duration of time. Automatically there is an uneven evaporation, resulting in uneven absorption of water by the concrete or surrounding. So this will also to be avoided. What are the results? How it look like this? You see here the size of the hole, small hole. I actually zoomed it, that's why you can see the bigger one. Like this time, the size of the hole. This is showing the surface of the beam or column. All right. After removing formwork, you can see these types of blowholes on the surface of the concrete due to, there are few reasons. Number one, the settlement is not even, right? Maybe it all resulted by a consolidation effect, right? But the results is like this. You have a blowholes, right? Blowholes due to uneven absorption of water, uneven settlement, and then sometimes at the surface. Sorry, this, if you take this as a surface and on top of this surface the formwork will be there, right? So if there's a gap between that surface and this one, also can cause holes. And here, see here, small type. This will be very dangerous. It need to be filled, need to be attended. Otherwise, later on, or it will cause room for all flora of fungi, all the fungi type of fungi to live in. So that slowly it will corrode the surface. It will remove all the surfaces, not corrode, erode. It will remove the surfaces, concrete surfaces, losing its strength. The purpose of the member and transfer of load is not even. And then other effects, uneven surface. See here, because of the concreting, you see here there's a some portion it is like this, some portion like this, some portion like this, right? Some concrete is still there, some concrete is removed, some concrete is over concreting, right? These types of uneven surface should be avoided, such a way that you construct the formwork very close. Don't leave gap between the formwork and the material or the final product. Otherwise, it will leave like this. Actually, this is a smoother surface, right? Where the formwork is nicely removed. But here, some of the material stuck to the surface, which cannot be removed. It will cause uneven surface, and later on, you need to remove all these to go for plastering or finishing. Surface treatment. Type of release agent to avoid defects. Okay, there are common problems we see: blowholes, uneven color, and there are other effects due to material itself, right? There are some type of surface treatment given here you can go for to avoid such problems in developing your formwork, constructing your formwork. Neat oil with or without surface surfactant, mold cream emulsion, chemical release agent, wax, barrier paint, water patched, or you can say water tied, water patched emulsions, right? Waterproof emulsions or water patched emulsions. So these types of chemicals, resins and chemicals can be coated before you use the formwork, so that there is a proper alignment between the formwork and the end of the concrete. It won't cause an uneven surface, it won't have holes, it won't break, right? And removal also easier. These are the different types. Not only in the all these emulsion, all these agents are not limited to this list. Every day you get in market different chemicals, but see that which one is suitable and read the labeling, right? What are the instructions given? Use it properly without any hazards. Causes of formwork failure. This is most important instruction for you. Inadequate bracing and scaffolding, especially when you go for high-rise buildings, right? Construction of slabs, roofs and slabs, roof slab, especially roof slab, construction of roof slab, which is at very high height. Care should be taken to check your formwork and scaffolding. More frequent, there is a separate section on scaffolding itself, where right now since we are attending formwork, which comes together. Formwork is all the siding, side panel, bottom panel, all these things. As scaffoldings are the poles that's going to support this. But I'm just giving you a glance for how the scaffolding is also to be made here, but there's a separate section on scaffolding, we'll see later. More frequent causes of formwork failure: inadequate cross bracing and horizontal bracing of shores is one of the factors most frequently involved in formwork accidents. You need to really go for a proper design, following the code books and the references to construct it, right? Number of cross bracings, horizontal, right? Number one is horizontal. Sometimes it is made up of horizontal and vertical. Sometimes there will be a cross bracing. And then the length also matter. You cannot go for a longer panel, longer pipes holding for a longer length, right? The length of the pipes, length of the horizontal, length of the vertical. If it is diagonal, and also the number of diagonals. All these things have to be properly designed, tested before you use. All the prefabricated formworks will have the value, how much load it can bear, how much ton it can hold. Properly calculate, recheck twice, thrice, then fix it. Then go for your concreting. Since you know how much concrete is, what are the loads that is going to come over, since you already calculate the dead load of the concrete, if it is the slab, dead load of the concrete and all the moving items, and also the side, the lateral loadings, it may be wind or other type of lateral loading, right? Deflections, all these things are calculated, and to that you check the one you purchase. Mostly we purchase this framework. We don't nowadays high-rise building, they don't construct it at the site, they will buy. So this has to be checked against the loading that is coming in. If it is a 40 kilonewton, then you check what is the load bearing capacity of this member, this column, or the formwork you're going to use, and then properly support it. Later, next comes the spacing. We will see in the next slide. First is the point load that is taken by this formwork, have to be checked properly for the overcoming, check against the overcoming load. Otherwise, the member will fail. Ultimately, your whole project is collapsed. Vibration. It's also taking in vibrations, right? The causes of formwork failure may be due to vibration. Sometimes that's why live load, it includes concreting, right? Concreting, moving, and then all types of vibrations, mortars used, and then the consolidation types. Here, if it is the chemical mixing, right? All these things you need to take into account. Sometimes collapse when there shows jack or displaced by the vibration cause. Yeah. Later when we go for scaffolding, hello, hi, sorry, excuse me, hi. One moment. He is not here. When we go for scaffolding, I will explain about each and every component part of the scaffolding. Then it is easy for you to understand. For now, bear in mind it should be firmly supported onto the ground, right? Later on, it is going to take up the load of the concrete, take up the load of the member which is built on top of it. So sometimes is done, passing traffic, movement of workers, the equipment on the formwork, the effect of vibrating. This live load, all types of live load has to be properly calculated, including the machines, machineries, people, wind. All these things have to be properly calculated to avoid any failure due to vibrations. Vibrations we cannot, we don't expect always, but at times it may happen. So you need to account for this vibration. All the when you account for all the live loads properly, you already accounted for the vibrations into it. You can even later, after all calculating, you can put some extra value like 50% extra or 20% extra. You are safe. That's how they are managing in real practice, in real construction. But you should not be overloading. That is also you have to keep in mind. Otherwise, you're wasting money on formwork. Causes of formwork failure: unstable soil under mud sills. Yeah, this is also a very dangerous issue. Formwork should be safe if it is adequately braced and constructed so all loads are carried to solid ground through the vertical members. Side drainage must be adequate to prevent a washout of soil supporting the mud sills. Yes, ultimately all the formworks, all the poles, all the what you call the pillars, which is supporting the formwork for the slab or the beam, which is at high rise, which is at a very high height, or ultimately supported onto the ground. Later I will show you the mud plate, a sill plate. We call this a sill plate or mud plate. Is the final point that is touching the ground, upon which your poles are standing. Your poles are firmly attached to the mud plate or the sill plate to hold the structure. So these has to be firmly supported onto the ground. When you say ground, you know, right? These are all working on the environment, open ground. Sometimes there may be rain, sometimes there may be, the building is still under construction, right? Although underground drainage systems are built, right, at this stage, although underground drainage systems are built, Pipelining may not be done yet, only surf underground. You just, all the waters are drained to the underground. Main line, you can say this as a main line, right? Main lane is built but not connected properly. In such a situation, you should provide proper arrangement for drainage. If there is a raining, right? If there is a chances of raining, all the rainwater should be collected out. Not there is no waterlogging, there is no problem for the scaffolding. You have to check before you go for concreting all this point. On the day, on the the concreting, right? That morning you have to go to the site early and check whether there is raining, whether there is each support you have to one by one. If it is 100 support, you have to check one by one whether each support has properly holding. Is there any problem, swampy or mashy land, right? Marshes, some kind of loose soil, right? Due to raining, you have to remove properly, harden it, and then go for construction. So this is quite common because there is no construction. These are all temporary construction. There is no proper foundation. It just rests on the muddy soil. So care should be taken, especially when it is raining. The day you are going for concrete, it has rained before or a day before. You should check properly one by one whether the proper supporting is there and no problem hazards due to this type of holes or the scaffoldings. Scaffolding supported by the surface, land surface. Oh, you can see here also some of the things. Right, these are the horizontal bracing. Can you see this? Wait, I take the laser point. Just understand the component parts. They are going to make this, for example, they are going to make this slab, right? This slab, roof slab. These are the white horizontal member is called guard rails, right? This is also rails, and this is also rails. This is also rails, and this is the toe board, which is going to bear the slab. You pour concrete onto it. This is the board, maybe wood or plastic. Later it will be removed. And this is also access gate. This is the ladder for the people to go in to pour the concrete. And then this is the plumb line, vertical line. They mark this as the initial point from which it will be cross-checked with the other poles whether they are straight or not. Using a theodolite, maybe it is a big building, they use the theodolite line of collimation. You check the line of collimation to see whether both are vertical or any inclination is there. They will adjust the support. And coming to the bottom portion, it's clear here. This is the bottom plate and the base plate, plate of this fabrication. This what you call the formwork, and this is the mud. Just see how loosely it is kept. Just sitting on the mud plate, mud sill, right? Mud packing. Onto that there is a base plate steel, and it is having the pipe welded onto the base plate. And it is erected, right? And then these are the cross bracings. This is what we said just now. The number of bracings have to be evenly spaced. You cannot be having for a whole length. You are having only one cross bracing, not like that. Chances of bending, right? So you should be properly designed such a way that number of bracings depending on the height or depending on the length it is running. So these cross bracings and the horizontal bracing should be properly planned, and the number should be maintained for successful formwork. This is why it's blurred. Just for you to imagine how these works are done at the site. You see high-rise one, flyover. They are constructing a flyover. This type of maybe they are going to have. These are the formwork, right? These are the formwork. This may be the station, right? This may be the station. They are going to have a construction here. It's always ugly and dirty at the site. It's a clear picture here. Crane. This is the crane, elevated crane, which is carrying the blocks, right? Carrying the blocks. And then these are the reinforcements, which will be removed, or which will be, I think this has to be removed, or it may be straightened later on for the construction. I don't know which place exactly, but there are chances like this, right? Like these type of locations. And the formwork have to be built at this height. Can you imagine the height? See here, very high, the height of the formwork. you have to decide which material, which mostly they go for steel. Okay, maybe over that they may be using the cross panel, maybe wooden or PVC. And then what else is one of the scattered material, scattered reinforcement at the side. Example 1. Okay. So we saw the materials and the drawbacks in the formwork. Any questions so far? Formwork materials, expected failures of formwork. Any question?
No,
How many of
miss.
you joined? I don't know why you people are not coming.
Miss, what is the difference between the scaffolding versus the formwork? Between scaffolding and formwork?
Differences. Formwork is mainly it is the sides, bottom, mostly the side and bottom is called as form. The form, the structure which is forming the column and beam or slab is called formwork. And if you are going to support it, right, the poles, the pillars, the piers that is going to support these types of forms are called scaffolding. We will have a separate section on scaffolding later. Okay. The side member, bottom member is called formwork. The poles that is going to support these types of forms are called scaffolding. Okay. Are you clear? Got it?
Yes.
Okay. You can see the video, right? Not video, the slide.
No.
One moment. Oh, yeah. Correct. Types of formwork. Is there any other question? He asked me difference between scaffolding and I will show you this. I will show you later with the members also. But formwork is the one which is forming the beam or column or the slab which you're going to construct. The member that is going to support a pole-like structure is called scaffolding. Mainly it is meant for that. Later we will see the member, the diameter of the scaffolding and the spacing, all those things. I will give a glance only in this chapter because it's also important. Later we will say the exclusive chapter on scaffolding. Right. Where and all you use this formwork? To construct your foundation, column, right? To construct your foundation, column, beam, slab, wall, climbing, maybe a staircase, or just what, flat, I mean, with the staircase with the steps or without steps, or any slopes, sliding, right? For sliding, you're constructing a slab for sliding, or permanent members. Mostly it is named as a a septic tank or a staircase or any basins or swimming pool. All those types of permanent structures will be built by using formwork. I will explain one by one the elements of the building in another section, maybe the next slide, for you to understand what is a beam, what is a slab, what are the sections of these types. I will explain in the next class, next slide. For now, understand these are the main members which it will be, which requires a formwork. Foundation construction, column construction, beam construction, slab construction, walls, construction of walls also like this. See, you can see in the video, construction of walls also needs the formwork. Climbing, maybe climbing by staircase or by just a slope, right? Or louvers. Louver types are all very new one nowadays. Sliding and permanence. And this is called sill level of the window, right? They go up to sill level of the window. Okay. The animation is very good for construction of formwork, so I brought it. Beam work. Beam forms must be designed and constructed to safely support. Number one is vertically applied dead loads and vertically applied live loads. So you see here, let's understand the members of this one first. Number one, we see here, this is the form. This is the form, right? Maybe a square beam. Square beam is being constructed. Plywood beam form. See, this is the formwork. And how is it supported? By these types. a slab from joist, right? This is a slab, it's a joist, right? Maybe they are continuing, that's why the beam will be continued with the slab. That's why they have a continued slab as well. So these are the framework it is used for supporting. And this is called kicker, T-head, different from different manufacturing. And one example is shown here, which is the form. The form is supported by these T-heads, diagonal brace, right? The T-heads are holded by, formed by a bracing or a diagonal brace. Shores, right? Shore, they call this as shore. The pole is called as shores here, and these are the sleepers. On sleepers, it is resting on. Okay, these shores or these poles are resting on the sleepers. So they use three shores. Generally, the spacing should be 1 meter, 1.5 the maximum. 1 meter, 1.5 is the spacing for any type of beam, right? For buildings, normal 3 meter high buildings, 1 meter spacing is necessary. And then what else? Okay. So these beams we are going to take, this formwork will take load of the concrete, load of the people moving in, right? And the machines which are carried over, and also the lateral loading, especially wind and other types of lateral loading. Another type of beam again, this is showing a beam. These are the N beam, they call this as a N beam. A PVC type of formwork used for construction of the beam. And see how they are supported. Again, they are using a T type of section and a pipe with the steel plate firm to the ground, just stuck to the ground, right? Just stuck to the ground. Maybe they use the bolt or another plate to support down. It is not really into the ground, just standing on the ground, supported on its own. And then what else? These are having cross bracings, right? Cross bracings. So inside also they have, inside and outside they follow by the cross bracings to support this type of beam. Okay, this is the beam construction, the scaffolding shown by, the formwork shown for beam construction. This may be a plinth level, sorry, we call this as, in your terms, it's a basement. From the ground, this is the ground, right? This is the beam, belt beam, we call this as a beam, belt. It's acting as a belt beam between the foundation and the superstructure, okay? We call this as a basement or a belt, right? Which is constructed to support transfer the load from the superstructure of the walls to the foundation. See here, after the foundation, it is little bit lower, little bit smaller than this one. A beam is constructed, and these steel type of shutters are used to form this beam. Okay, to form this beam. It may be beam or wall, but to me it seems like a beam because the reinforcement stops here. Later on, it will be continued by the walls. Okay, so this is beam. This is how steel shutters are used for forming your beam. Foundation is all below. All these foundation solutions. Foundations are always below the ground. When it comes to the top, it may be called as a basement or a plinth level. We call this as a plinth level. Some more. 15 mm thick plywood. They use. Last time it was a steel, and before that it was a PVC. Now is a plywood, thin plywood. It can the choice of this plywood results in a smooth surface but lightweight. Customization is easier. Many advantages are there using plywood. 21 mm thick plywood soffit is used, right? Soffit supports the joints, right? The soffit, I will show the soffit section later in a bigger dimension, easy for you. The corners are supported properly by the this cross head and the bracings, right? The bracing, the strut, the cleat, all these types of supports are necessary for supporting a plywood, similar to the steel and wood, but the names are different. Materials, mostly they are using steel. These are all steel. These are all steel. Okay, this is the plywood. And see the props, they use the props. This is called props. Here they call this as prop. Last time it was called as shore, right? Sometimes prop or pole or shore, the vertical member. Column framework. So after beam is a column, beam forms are especially susceptible to large lateral forces exerted due to high rates of placement of wet concrete. Tighter joints and bottom lateral supports is critical for this type of formwork. Why? One moment, I is confused between these two. Joints and spelling mistake. One moment. Can you answer this question? There is a question for you. Beam forms, and this is column 1, but there's a question on beam. Beam forms are especially susceptible to large lateral forces. Why? Quickly. Any idea? Just imagine you're constructing a beam, right? Tighter joints and bottom lateral support is critical for this type of formwork. I should take the beam one. Tighter joints, right? Tighter joints and supports are required due to the reason also given to you already, right? Due to high rates of placement of wet concrete. Tighter joints and bottom lateral support is critical, right? Lateral support is critical for this type of formwork. Why? Any idea? No, ventilation is good. Beam, no, there's no such thing. It's in the column. Problem of ventilation is in the column. You see, this is the beam member. Huh? Beam member. The question is maintaining a tight joint, right? Maintaining a tight joint, avoiding lateral for loads or lateral sway or crucial. Why? Tight joints are,
Prevent the leakage.
yeah, why? There is a leakage. Why? No, it's crucial. Huh? It's crucial or challenging for engineers to maintain a tight joint in beams. Why? The member is long, isn't it? The member is long. Lengthwise is long, right? Breadth is less, isn't it? If it is a slab, it has a breadth and width. But when it comes to beam, it has smaller width, but the length is very long, isn't it? Length is very long. You cannot pour concrete for a very long length, right? They do part by part, right? If it is precast also, again the joints problem. Either it may be a precast one or the form. When you talk about the formwork, it should be in situ. When you start pouring concrete, right? You cannot pour at one stage, right? You start pouring here, and then parcel by parcel you will be doing it. The concreting cannot be done at one stretch, isn't it? Concreting is done for the whole length of the beam, part by part. So in doing so, you have to take care of the joints. You finish one part, and the next part when it comes, you have to properly connect them together. That's why they leave an uneven surface and then they join by next parcel. So the difficulty is maintaining the proper joints, or how you close these joints, how you continue with the beam work, which is extending in a length direction. If it is pouring a column, is easier, right? You pour it, consolidate one by one. Even here also there is a chance of joints problem, especially the piling. If it comes to piling, you do one after another, you have to properly weld it, join it, and then pile on to it, right? One after another. Joints problem is there everywhere, but in comes to column beam, right? Column it's manageable. Beam, because of its length, because the whole area is exposed, right? Whole area is exposed. You have to care should be taken to maintain a tight joint. Avoid delay, avoid finishing, right? Don't leave smooth surface. There should be an uneven surface so that it will be started with proper, it will have proper joint. The next parcel, next. part of the beam will be properly connected to the previous one. That is one thing. When you go to the site on training, you will know all these things. You have to see personally how they are doing it, right? Okay. So if you don't construct the joints properly, it will lead to lateral yielding, deflections, all those problems. Right. Column formwork. The biggest column, roadway, maybe highway buildings, highway, or maybe intake structure or bridges can be constructed using this type. Reinforcement is there. They build the formwork, support it nicely, and then build the reinforcement, start pouring concrete. It's like this. One of the formwork is showing like this. Woodwork. There are different component parts shown here. I will explain one. You can go through others yourself. But different types. Let's see one. Opening for a beam. This is the opening with all the reinforcement inside, right? And then this is located around the kicker, right? Around the kicker. Fillet to form the chamfer, right? Fillet means just a offset, a kind of offset is provided for the formwork, for the concreting. Margin piece, right? And then the formwork panel of boards or sheets or material. Yeah.
The slide is freeze.
Freeze.
Yeah, at the column formwork there.
Okay.
Okay, thank you, Miss.
Can you see now? Can you see now?
Yes, Miss.
Yes, Miss.
Yes.
So this is showing the when you have different types of column formworks here. Let me explain one by one. Maybe I start from here. It's very clear. Okay, the topmost portion is a box like. If it is a column, depending on the cross section, it will follow the formwork. We have time, right? It's a box type, and these are the supporting structures for the form. What are the supporting structure? How it is supported? There is a number one. It's good if you see the original one. Later I will give you the all the component parts in photograph when you go for scaffolding. Support, how you support the formwork itself. For now, just understand the terms. They use the steel wedge, hook like. This is the pin. This is the pin. They just lock it, and then slotted steel blade, right? The steel blade is connecting these two, and then this runner and this runner is locked by this pin. And then here the same arrangement is there in all over the structures, right? Horizontal and this side and this side is locked by a pin, and these two are supporting this formwork. Like this, you can see different arrangement of the formwork, right? When it go to scaffolding, I will show with the real photographs, easy for you to understand. Just keep this for your reference later, right? Typical beam and slab formwork. Can you see the slide?
Yes, Miss.
This is the beam. This is the beam. This is the slab. Normally, they go for concreting together. Beams and columns are done together because it's a continuous member. You have to do it on one day. They may even go for 48 hours together, shifting with the shifting people. They will go for continuous. If it's a big roofing, they will go for continuous 48 hours, 72 hours also they will go for, right? See here, beam and the slab, beam and the slab. Okay, how it is supported. This is the cross bracing is there, right? Start from ground. We start from ground, right? Base plate, right? Just standing on the plate. The plate is on the ground, right? Just fix on the ground. It's a plate. Just put the plate on the ground. From there, the folding wedges are there, right? The wedges starting. The folding wedges will raise the length. Keep on increasing the length. Useful for increasing the length. And then it goes up, right? Goes up with all the cross bracings to support the plate, this plate, right? And then and the soffit is clear here. Soffit is the bottommost portion. Inner bottommost portion of the beam is called soffit. Okay, soffit point is important. They have to use the laser pointer to check whether it's level. Otherwise, beam will be beam will be inclined. So the soffit level has to be properly checked. Inner bottommost part of the formwork is called soffit. And then the plywood goes up like this. It will be a little bit higher, can be a little bit higher than the beam. Okay, what else? Another support, the middle support is like this. Middle support is like this with a collar, with the alternate timber props, right? You can also alternate with the material steel and timber wherever it is applicable. Like that's called composite member. A scaffolding can be a composite member like this, and same arrangement is found here to support a beam and a slab. Sky deck slab formwork. Sky deck. Again, a composite material you are seeing. Yeah, some steel work, right? This seems steel, all steel type, and then this one also steel. Okay, it's also steel, I think. Yeah, steel. Skydeck slab former is an example one. And just to show you the spacing, I brought this to show you the spacing. Hardly should be 1 meter or 1.5 meter spacing. See how nicely they arranged it. They all evenly arranged with the proper spacing, with the proper numbers and support structures. Support structures, the pins, the ties, the flanges should be anchored properly. This is the formwork for roof. This is the deck, slab deck, and these are the scaffoldings. Okay, he's lifting it. Maybe he's working. He's working, and he's during working. Striking of formwork. The period before striking is dependent on concrete used, weather, and exposure of the site, any subsequent treatment to be given to the concrete, the method of curing, and other factors. The spacing should be equal to 1 meter center to center. Center to center is important, very important matter. All the scaffolding should be center to center is 1 meter, and the top, it may be a beam, it may be a slab, it may be a toe board, all should be sitting at the center of the they have to mark, they have to draw the position and then mark it, position it to the point where it is marked exactly. Avoid any lateral bending or movement, the displacement, so that the structure is safe, right? Spacing and fixing the striking is very important. According to the drawing, you need to follow according to the drawing. So the duration depends on the concrete use, right? The grade use and the curing time, and the weather and the exposure of the site. All the timing, the holding time for the formwork will depend on these weather condition. If it is cold weather, you have to prolong it, not 24 hours, 24 days or 30 days for the slab. You have to extend it. Any subsequent treatment you can use in those places. You can use quick setting or any admixtures which can enhance your duration of setting. The method of curing also affect the duration of striking of formwork. The space striking means holding the retention period of your formwork. The spacing should be equal to 1 meter center to center, or hardly 1.5 meter if it is really if you're firm enough and the material is good and it is a new brand fabrication, you can use 1.5 hardly. Wooden, this is another example of spacing. Again, I brought this to show you spacing. 1 meter, 1 meter, here to here is 1 meter, here to here is 1 meter, like this. And then this panel is steel and wood. Steel, the steel is supported by this wood. They didn't use wood because the slab, you use wood, all concrete will, water will be absorbed by the wood. So they use the panel as a steel and the supporting as the wood. Here only I'm telling the center to center, and this pole should be exactly sitting below this beam. Should not be shifted here or shifted here. Care should be taken to position this pole or strike this pole exactly at the middle of this or within this material. Cannot be thrown this side or this side. And then the center to center distance should be maintained. The diameter also matter. I will explain that later. Only when concrete is strong enough and able to carry imposed load, soffit forms to beam and slabs must be left in place longer than the side forms, should be with care and slowly to avoid damage and shock load on the partly hardened concrete. So again, some other conditions are, it should be strong enough, right? It should be strong enough to, when you pour, should be strong enough to hold it. And the bottom portion of soffit forms, the bottommost will form the soffit of the beam, and the slab must be left in place longer than the side forms. Yeah, we need to remove the sides first. then go for bottom. Okay, that's what it says. You need to leave longer the bottommost. I will show you later. When you go for scaffolding, we will teach all these things clearly with the pictures. But when you remove formwork, go for sides first and then the bottom. Leave the bottom for another 1 week or 10 days. Should be with care and slowly to avoid. You cannot be hammer it very fast, right? To remove the formworks on the sides, you should not hammer it fast. Care should be taken while concreting itself to apply proper resins or proper chemicals to safely remove or stripe off the formworks. Size of the ball is, see, the wooden ball is a wooden poles maybe 10 centimeter dia. Can you imagine 10 centimeter dia like this? 10 centimeter dia mid height and then 80 mm dia at the end. Okay, middle scaffoldings can have 100, the end can have 80 meter, right? The middle is going to have more, so all the middle poles can be used as a 100 meter 110 centimeter dia poles. Ends can be 8 centimeter poles. Shuttering of the beam should be removed first. Yeah, the side parts should be removed first, followed by bottom of the slab shuttering. Lastly, shuttering forming bottom of the beam to be removed. That's what I said just now. Centering up to a span of 4.5 meter can be removed after. Yeah, so all them centering means the poles and the slabs. The slabs. The bottom slabs are called centering. Centering up to span of 4.5 meter can be removed after 7 days. Centering span over 4.5 meter to be removed after 14 days. So after removing the sides, the bottommost again having the duration. If it is just 5 meter, around 5 meter, 5 meter you can imagine, right? 5 tubes, 5 meter, part by part you can remove. Just remove 5 meter, leave the next alternate 5 meter you can remove, and then after 14 days you can remove the whole. So care should be taken to remove the forms and the centering. Centering means the scaffolding, the poles and the bottom plates have to be removed term by term or time to time. Okay, not at one stretch. It's all written in the code book. How many days for the formwork, scaffolding, all there you can follow. But generally, leave for 7 days for the alternate centerings, 14 days for the all of them, removing all of them. When you talk about the centering or the scaffolding removal, shattering of the beam should be, it's done already, right? Oh, it's clearly written here about the temperature and the number of days. This is important. I will ask in the, just memorize at least 1 or 2, few of them. Only 4, right? 4 here. You can memorize and keep in mind. Duration of formwork removal. Vertical formwork 12 hours. If it is room temperature of that place is 16 degree, room temperature is 17 degree. Take this as a reference one for you. Normally 16 degrees the temperature for most of the places in tropical region. So vertical formworks can be removed in 12 hours. We have time, right? And soffit, the slab bottom can be removed by 4 days. Removal of props, the poles maybe 10 days. Beam soffit should be 10 days. Below the beam you can remove by 10 days. Removal of props by 14 days. All the props by 14 days. Bear in mind, all the bottom one care should be taken. This one soffit, slab soffit 4, beam soffit 10 days, vertical 12 hours. Within 12 hours we can remove. It depends on the grade you are using. You have to cross check with the grading. In general, any M15, M20 can be removed like this. Curing. So all of you know the purpose of curing, right? Curing is, this is the last slide. Let me finish and go for your company quizzes. I think I have quizzes today. Means, can we have quiz or continue with the class today? Continue the class, right? Okay. Means controlling the moisture content and the temperature of the concrete after placing, right? Means controlling the moisture. You need to control the moisture, dry it, then only you say it is proper setting, you reach the strength. Important to develop concrete strength. Curing is important to develop its strength. Excessive evaporation may cause multiple surface cracks. Excessive evaporation should also be avoided. Excessive absorption during concrete also should be avoided because you already mix the proportioned water. You maintain after the removal of the formwork. Curing him immediately after removal of the formwork, start curing water, keeping water, maintaining water, so that all the pores are filled properly. There is a chance for further hardening, further settling of the concrete. Most effective method of curing, cover with waterproof sheets. Yeah, above all, I don't know whether it's written here. Okay, the cover is important. Cover between the reinforcement and the bottom, right? Cover between the reinforcement and the bottom needs to be properly checked all through the concreting. Some places the stone has gone out, right? During people are working, the stone will be removed. By that it will go down. The reinforcement will go down, touching the formwork itself. That case, you can see the steel member out, right? You can even see the steel member outside. No concrete surfacing on top of it. Such things have to be avoided by properly checking the cover at distance, right? At distance, it will be at distance, uh, especially at the ends and the middle points, so that the concrete is covering the reinforcement. Cover with waterproof sheets. Building, yep. Sometimes the evaporation is very high, right? During that time, you just cover with the sheet, pour water and cover with the sheet, so that there is a chance of concrete to be in contact with water for longer during the curing period, right? So maintain all these things. Care should be taken for proper curing, proper settling of the concrete until it's reaching the strength. So what are things you can use for cushion of water? Polythene, what building paper, polythene, damp sand, damp sawdust, wet cloth. Just spread the wet cloth. Mostly they use wet cloth. Wet cloth are the plastics. They cover with the plastic. I see plastics most of them. They use plastics to. They were using those things to cover their cement and sand loaded at the side. Later they cover their concreting surface so that it will be curing and then no wastage of water. The time duration is not longer. Website you can go in, very nice videos are there, selected videos for you to understand how the formwork is built, how the formwork. Actually here in this video I cannot show all the videos, because there are nice videos to show the tools, right? How he is using the tools, how he is fixing the formwork, and then what are the safety measures during formwork, all are there. If you want, we can see one video. It was very nice. Actually I posted here. Don't know. Let me check. I posted one video here for you to go through. I can't remember now because I did it last week. One moment. Not this one. One moment, sir. This video, you can see later all these videos. It's all self-explanatory. You can go through the application. Connect with the charger. 1 minute, please. I was sitting at the door side so that you can see me when you come inside our room. But no one is here, unfortunately. 1 moment, I go to this class. Okay. Are you there? I choose one video, very nice one to show you. Very good. Doesn't matter, you can see the videos yourself. I continue with the class. One minute, sir. Give me a minute. One minute, sir. Homework design requirement we are going through, right? Okay, doesn't matter. I cannot pick that video. It has all the safety measures, what you have to follow in the site. I request you to go through all these. Can you see the links here? Can you see the links?
Yes.
Please go through these videos for your better understanding on how the tools are used, what are the tools and how they are fixed to form the formwork and the scaffoldings at the site. Now I move on to the next topic. How many of you joined? 105 only. What happened to others? Only 105. Where are they? Why I cannot get this?
Then will we have a quiz for attendance today?
Yeah, can I? One moment. I cannot get my. In the beginning, I forgot to control the things. Like when I came to the class, I didn't do the editing, the setting up. Somebody removed something else. Let me check. When I came out and go inside. 1 minute, I'll why I cannot get this people section. Oh, it's here. Okay, I got it. Right, let me continue with the next slide. Next slide on scaffolding. Is that okay? Is that okay? We have 20 minutes. Yeah, better. Let me finish the topics. I can even post the pieces for today. Because I need to complete the things. Okay, start with scaffolding. Only for today I posted. Oh, no, you got sharing scaffolding. Can you see the word scaffolding?
Yes, ma'am.
To understand the scaffolding matters even better than what you are having in mind right now, it's good I do this one first. Building components, chapter 8. So what are the building components you have come across? Before the scaffolding, I have to explain the components so that you know what are the components you have to support during scaffolding. Answer me, what are the building components quickly?
The roof?
Roof, We can't
The
say
wall
this is a roof.
walls.
Okay, you can say roof, roof, beam, column, slab, staircase, foundation, right? All these things are building components. Doors, windows, you can take, but we sometimes we don't. Doors and windows are fixtures, right? We don't construct, so we don't call that as a component of a building. Here it is referring to building components which needs to be constructed, right? Concrete structure, steel structure, composite structure, right? For construction of building components, you can use these types. Do you have any other type? Quickly. It's only 3 types given. I'm not convinced with these 3 types. I'm very greedy. Tell me quickly, what are the other materials you can use? Anybody?
Ma'am, for rooms, can we use a plywood type?
Wood, very good. I thought of this. Wooden buildings in Sarawak, ancient. If you go to a museum and all, not museum, even people are using it. Ancient buildings in Malaysia, most of the regions in where it's always raining. They have to keep moving. They have to what is called. Uh, in water, the structure is in water, right? All these things they use wood because steel get corroded, right? And concrete also slowly get broken, right? Brittle, absorb more water, but they use wooden pieces so that it is cost effective. They can dismantle, they construct back easily, and it is cost effective. They can move easily from place to place. All the water retaining structures which are constructed in the canal, you see buildings are constructed in canal, across the canal. And there is a canal, I think Egypt, I think it's in Egypt. There's a canal separating two buildings. Two streets are separated by canal, not road. So these people have to go to another street through boat or any other waterways only. They have to travel through waterways. So like these type of structures in water, structures where there is a raining, quite often there is a raining, they keep moving, they have to keep moving, movable houses. And then what else? They want to build a cost-effective, cheaper material, cost-effective construction. They go for wood material. And then building consists of slabs, beams, columns, walls, right? Building component, building component. You're going to build. The components which you will build in any construction will be slabs, beams, columns, and walls, mostly. Come on. These are the things you can see. This is the column, right? Where is there is a reinforcement, main rods, and this is a reinforcement beam, the reinforcement inside. And these beams are of these shapes. Okay, the cross section can be a height section, channel section, square section, angle section, T section. I repeat once again. This is column, right? This is column.
Miss, we cannot see your slide.
Why you didn't?
Where we
Miss,
study?
you're still on the first slide.
Yes, it is fixed.
You didn't. I asked whether the scaffolding you can see or not. Nobody answered. Can you see now?
Ma'am, let's start.
Yes.
Can you see? Can you see the section, I section, H section,
Yes.
channel section? One more answer. Can you see the sections?
Yes, miss.
Oh,
Yes.
thank you.
Yes, Miss.
This column can be circular. This column can be circular or of these sections. Okay. I repeat. You are seeing the concreting and the column which is a reinforced column. These are the reinforcement inside. Main bars are there. And these are the main bars and secondary bars all around. And then this one is the horizontal ones are secondary bars, and these are the main rods. You will be designing later. And this is the concrete with the reinforcement. It's a column. This section can be circular like this, or if it is a steel member, fabricated member, they'll use I section. Sometimes it's called H. To me, it's I only. You can take it to be H or I. Here it's written H, so use H. H section, they have to turn it. H section, channel section, square section, angle section, and T section. All right. Do you remember moment of inertia? Moment of inertia.
Yes, Miss.
How do you calculate?
BH cube divided by
No, la. What is moment of inertia? Okay, before I go into moment of inertia, all these things, I want to show this one. This section, this moment of inertia can be calculated by using online sources. There are predefined formula and websites available wherein I can explain you the component parts of the section. That's why I brought it here, not for calculation of moment of inertia. Calculation of moment of inertia you will study in statics and dynamics or mechanics of materials. Okay, in one word, if we say moment of inertia, inertia due to the material, the self-weight, the body and the sections are stable, strong enough due to its own weight, right? I am 60 kg, I am 80 kg, right? That's why I can resist the atmospheric pressure or anything that is coming. If any 80 kg, I'm 80 kg means 80 kg people coming and attack me, I can withstand, right? It's because of my own inertia, my own weight, isn't it? That is called, in simple word, if you want to explain, moment of inertia is the strength or weight due to its own inertia, its own weight, self weight of the material, right? Borne by self weight of the material, no other. If the section is 100 ton, it can bear 100 ton. That is the that is how the moment of inertia works. It's all about the material content or weight of the material inside. In this is important when you want to use this member as a column or a beam or a slab, right? This is most important. You should know what is the moment of inertia of that particular member. It is all written in the code book. Later, when you go for steel structure or RCC structure, you will directly refer from the code book. You can have the section, dimensions, and the values. How to read the table, that's what I'm going to teach you now. Okay, how to read the table and the manuals later on when you go for designing, when you choose the section for your construction. Come on, can you see this slide? You can see the slide or not? The website
Yes,
Sky,
ma'am, we can see it.
Sky CV. There are many types of moment of inertia calculation, but I picked this one, very simple one, wherein you can understand. No, not this one. Okay, I go by this. Actually, I selected this section. You can see different types of sections here. Oh, it's on top, I think. Okay, let me finish this one first. Okay, for example, I section or a H section will be looking like this. Oh, it's here. See here. Can you see the different types of members? Rectangular. Can you see? Can you see or not?
Yes, please.
Yes.
Rectangular, hollow circular, I-beam, T-beam, L-beam, channel, and triangular beam. These are the different types you can calculate easily based on the members. What are the members it has? For example, if you take rectangular, it's like this. It has breadth and
Miss,
height. Yes.
what time do you have quiz?
Today I assign it because I need to complete the syllabus. Shall I assign it? You can play later. Okay. I will assign the quiz later on. I will give you time, don't worry. Okay? Okay?
Okay.
Good.
If you take I-beam, you see here I-beam, it's important you should know what are the things. This one, top width. This one, this is called web, this is called flange. Okay? Top flange, bottom flange. You can call this as I or H, whatever it is. But here it is, we selected I-beam. For I-beam, the horizontal members are called as flanges. The vertical members are called as web. Okay, and this one is the width of the flange, thickness of the flange, and this one is thickness of the web, the height of the web. This is thickness of the bottom flange, width of the bottom flange. Sometimes it comes with the same size, sometimes they are different. Here it is different. That's why you need to calculate separately. Similarly, if you go to triangular, L beam. Yes?
Can I see the slide?
The website I'm showing on the website. You cannot see?
I cannot see your screen.
Okay. Others? Any other? Cannot see the website I'm showing, I'm sharing with you?
Yes, I can.
Can
I
see.
can.
Can see.
You please quit and restart Restart your website or restart your team. You will see. Those who cannot see, please restart. Okay, can you all see now? Now L-beam. L-beam.
No, ma'am, cannot see.
Cannot see. What's happening? Did it just now?
I think it's stuck.
Huh? Got it? You can see now?
Yes.
Yes.
L-beam. See here, L-beam. Again, we have this is the web. This is the flange. Okay. Length of the this is bottom flange. Yeah? Flange width, flange thickness, height of the. They call this is. This also flange. Yeah? They call bottom width, bottom thickness, right? Bottom thickness, bottom width, and left height, left thickness. They call left and right. They call these two as a flange in this case. So you need to use thickness and height, thickness and width. That's all. So you need to understand the component parts, otherwise you'll be calculating wrongly. And this is easier. This is the web and this is the flange. Okay, height of the web, thickness of the web, width of the web, thickness of the flange, width of the flange, thickness of the flange. So like this, you have to mark carefully what are the dimension. If you calculate, just put 2, 3 like that, it will calculate automatically. Width of the flange, I put 3. Thickness as the 0.1. You need to choose the unit. I don't know where the. Later you can run through this exercise. Okay. Choose the unit properly. Here mm. It's in mm. It's here in mm. So I put it in centimeter. Easy for me to calculate. Imagine and calculator. So 30 centimeter, and this is for row. So choose the dimensions, choose the measurement, click, you can calculate the where is it going? It can calculate the your what do you call moment of inertia wisely, okay, without any mistake. You can even compare your manual answer with the formula you are using. There are different formula. What is the unit for moment of inertia? Mm per centimeter per 4. That's all. Okay, centimeter per 4 is double times the area, meaning the self weight. Unit weight is included. Unit weight of the material is included in it. Based on that, the strength can be. It will be a guess for strength of the material. And then continue. Oh, it's already time up. I'll continue in the next class. For your what do you call your quizzes, I will post. Is that okay? Or we play next class?
Next class, miss. We have a lot of time.
Next
class,
miss.
Okay, we do it next class. No problem. I
Ma'am,
stop
it's
here.
already.
I stop here. Why
Yes, thank you.
Oh yeah, I don't know what happened to this 10 people. About 9 people missing today. Try to attend classes in person, right? It'll be easier. If you want to clarify any questions, you can clarify. I stop here for today. If you have any questions, please ask me through message or call me. Okay. Bye bye. See you next class.
Okay, ma'am.